Hello, so today we will talk about divergent test. For divergent test, it's said if the limit of k to infinity of a of k different than 0, which means limit of k to infinity of a of k can be equal with positive infinity, negative infinity, or any number. So the series of a of k will diverge. It's just easy like this. One thing I really want to notice, you guys, is just like you just can use divergent test to conclude the series is divergent. No conclusions for using divergent test for the series converge. What I mean so far, it doesn't mean that like if limit of k to infinity of a of k equals 0, the series of a of k will be converged. It doesn't mean this way. Doesn't mean this way. So please, when you see the limit of the functions a of k equals 0, you have to use another test. For divergent test, you can use the third properties that this for the series a of n plus b of n or minus at series a of n is diverge and series b of n is converge or diverge, then the series a of n plus or minus with b of n is diverge. So it means like either a of n or b of n has to be diverged to conclude the series a of n plus or minus with b of n is divergent. So I have three series. The question is find the series is converge or diverge. Okay, the first series you can see so far, you can take limit of k to infinity of k to 2k plus 1. You can use L'Hopital rules. So I can have limit of k to infinity of 1 to 2, which is equal 1/2. So it's different than 0, so we can conclude the series infinity to k to 0 of k over 2k plus 1 is diverge. Based on divergent test. The series number 2 is much easier. For the series number 2, so we have k over ln k. So once again I use limit of k to infinity of k to ln k. Use L'Hopital rules again. So we have ln of k to infinity of k, which is infinity, different than 0. So the series diverge based on divergence test. For the third one, so limit of k to infinity of 10k squared plus 2 over 3k squared plus 1. I divide both sides by k squared. The numerator and denominators divided by k squared, so that I have an equal with limit of k to infinity of 10 plus with 2 over k squared over 3 plus with 1 over k squared. I know that like limit of k to infinity of 2 over k squared, this one equals 0, this one also equals 0, so this one is 10 over 3, so this one is different than 0, so diverges. And then based on divergence test. That is all for divergence test. For p-series test, add a series k equals 1 over kp, converge for p is bigger than 1 and diverge for p is smaller or equal to 1. I have some questions. The series of k equals 1 of 1 over 5 to the k third, and then the series of k equal with 1 of k3 over k5. So for these three of series, find the series converge or diverge. The first series, this one, I know this one equal the series of 1 over k to the 3 over 5th, and 3 over 5th is smaller than 1 or equal to 1, so this one is diverge. And this one we have to simplify it first, so it's gonna change to this numbers. It's gonna be 1 over k squared. 2 is bigger than 1, so this one is the series is converge based on p series. This one we change the series into 1 over k to the 4th is bigger than 1, so the series also converge based on p series. So that for p series test there is 2 qualifications. At first, simplified the equations or the series first, and then it has to be numerators over the denominator. The numerator has to be some numbers. It cannot contain any unknown value, which is just like k or n. For example, like the series of k equals 1, and then it's just like k over k squared plus 1. We cannot use p-series test. Or even like this one, it's just hard to should not use p-series test at first. We should use some things like comparison test, and then we use p-series test. Basically, it has to be the formulas of like number which is constant, over k to the p. That is the formulas for p-series test. If it's different than these kind of formulas, then you shouldn't use. If it's different, should not use p-series test at first. Used another test, for example comparison test, and then use p-series. For harmonic series, can be simplified as k equal with any numbers constant, but it should not be fraction, like any constant like 1, 2, 3, 4 more, and then 1 over k times c. C is also the constant. For example, k equal 1 of 2k. This is the harmonic series. Or even 1 over k, this also harmonic series. However, so the harmonic series is just like a sum of like 1 plus with 1 over 2 plus 1 over 3 plus 1 over 4, so on more, but it would not be harmonic series if the sign is changed. For example, sum of 1 minus 1/2 plus 1 to the third minus 1 to the fourth. This series likely to be k equal 1 of minus 1 k over k. It would not be this case also. The sums of 1 over 1 plus 1 over 3 plus 1 over 5 plus 1 over 7, because the series of this one, the formula for this series is 1 over k plus 2. Once again, harmonic series is just the series of k equal 1 or any numbers of 1 over c times k. C is also any numbers. Or even this one is also harmonic series of a over c times k. A and c is any constant. For harmonic series, always diverge.